Hi everyone. Welcome to to another distinguished lecture in the Portland Technology Management School of Thought, as they say. This is Turul Daim, and we are very privileged to have Dr. P.VanDerSchaf with us today from Oregon Health and Sciences University. He's going to talk about adoption of health information technologies. I'm going to let him provide an introduction to his bio as well as what he's going to talk about. So with that, it's all yours, Hans, and you can also share your screen.
Okay, that sounds great. Thank you, Dr. Dime. Pleased to be here today. I'm going to share my screen and let's see. Okay, so are you seeing a full screen that says Determinants of Student Information Technology Adoption?
Yes.
Yes.
Okay, great. Awesome. Well, thank you. It's wonderful to be here today. Excited to talk with you about the research that I've recently completed around why students may or may not use technology and how that relates to service innovation. Forward to my next slide. So a little bit about me. It's wonderful to be here to share with you today. I'm really energized by technology and service improvements that create big changes in organizational performance and improve customer experiences. I'm also energized by my family and being outside. Here's a picture of me on a backpacking trip in Central Washington this summer. As Dr. Dime mentioned, my work is at Oregon Health and Science University here in Portland, Oregon, where I champion OHSU Health's mission to make care available to Oregonians by focusing on digital health technology innovations. I'm a proud alum of the Engineering and Technology Management Department at Portland State University, where I earned my PhD in technology management, and I also have a master's in public administration from Portland State as well, and a Bachelor of Science degree from Ithaca College. So a little bit of introduction. This research was conducted for the dissertation for my PhD. I had a wonderful dissertation committee, including Dr. Dime, Dr. Mark-On, Dr. Nuri Basoglu, and Dr. Bob Fountain. Wonderful folks that really helped me guide my research. And if you're interested, the dissertation that I developed under their guidance is here at this URL. Which is also the Portland State University Library Open Dissertations website. So lots of acknowledgements before I jump in. My committee, who I just mentioned, my former colleagues at Portland State University students who participated, as well as experts from Portland and across the country, and my family, who just provided a ton of support as I was doing this research. And I really hope that the research honors everyone's engagement and is helpful to Portland State and other institutions across the country. So by way of additional introduction, the unit of analysis for the research was a software platform called MyPSU. It's available as a native mobile application and a website, and it was the unit of analysis for the research. You can see it has functionality related to classes, finances, school tools, which are other technology platforms, and then resources and support for academic planning as well. And it kind of serves as a gateway and aggregator of the most important things for students to focus on. It's available for both undergraduate students and graduate students, although my research focused on undergraduate student use of this platform. So the research objective that I set out to accomplish was to contribute to institutional, academic, and educational technology sector efforts to dramatically enhance service quality in support of improving undergraduate student outcomes, which is essentially undergraduate student persistence and graduation, by identifying the determinants of student information technology adoption, and had two research questions. Research question one over here is, what are the critical factors that influence undergraduates themselves in adopting software like MyPSU, which is around accessing university services? And research question two was, what degree does the unified theory of acceptance and use of technology, UTAUT, how does this model predict technology adoption? And we'll get into both of those questions in the next few minutes. I mentioned the unit of analysis, and the target population was undergraduate students at Portland State. The purpose of the research, higher education institutions are stressed. At the time this research was happening, there were regular kind of budget pressures that were happening as a result in some ways of economic pressures and performance pressures. And added to that, in the past few months, the COVID pandemic and how that's influenced instruction in universities, and they're just facing a lot of pressure. Yet at the same time, a college degree still creates tremendous value, increased social mobility, increased lifetime earnings and civic engagement, and a more future-prepared workforce. Yet we still have large performance gaps to address. Attainment rates across the country are well below what would be ideal, and 1 in 3 college students who enroll never earn a degree. Clearly a lot of opportunity for improvement. And so that work in improving degree attainment or student success is really critical. It's defined as supporting undergraduate students with remaining enrolled in college until degree completion. And I really think that technology can help play a central role, particularly even now as a lot of learning is delivered remotely here in the US as a result of COVID, where consumers expect personalized services and organizations can leverage technology to create operating leverage, personalized services, reduce costs, and solve mission critical problems. And so in this space, then student information technology supports service delivery innovation. And we define this body of technology or technologies that support staff and faculty with improving undergraduate retention and graduation, and student-facing technology related to academic success and accessing university services. So we think about the importance of the research topic. I've talked a little bit about this, but from an economic perspective, we think that institutions can really use e-services enhancements or software platforms like MyPSU to really differentiate their service offerings and create a sustained competitive advantage. From a social perspective, I talked about the value of an educated citizenry, more workers with college degrees, and increased social mobility. From a technical perspective, I really want to highlight that organizations must manage their service delivery to enhance the customer experience. And that continues to be true today as well. And this sits within the context of US goals to improve college attainment. I mentioned before some of the challenges and opportunities we have to help more students complete their post-secondary degrees within 4 or 6 years. And there's a huge potential. The student body in the US is quite large, tens of millions of students with a really, really large ed tech sector. And so this research in summary contributes to economic, social, and technology-based goals, including goals in the US to improve university services and college attainment. So this is a summary of the research approach that I took in the research. First, conducted a literature review to identify the factors related to student information technology adoption. Out of that work, created a preliminary research model that was improved and enhanced by interviews and focus groups. Then conducted a survey of Portland State University undergraduates based on the model, and then conducted statistical analysis of the research model using the survey data and an analytical approach called structural equation modeling. And that led to the results and implications. And so in summary, this research used a robust mixed methods approach. So a little bit about Portland State University, if you're not familiar with it. It's located in Portland, Oregon, offers more than 200 degree programs, and serves approximately 26,000 students. A large proportion of those are undergraduate students, and a decently significant size are graduate students as well. The students at Portland State mirror, I think, what many are calling the new traditional students. In the past may have been called non-traditional students, where many are full-time, but also increasingly large share are part-time. Many of them are the first in their families to attend college, or what's called first-generation college students. Many have children, and often many have high financial need. Portland State describes itself as Portland's public research university and Oregon's most affordable research university. So the work for MyPSU started under an initiative of Portland State to build the best student experience. And so MyPSU was launched as part of this effort to reimagine the student experience and innovate service delivery. You can see the work here from MyPSU really as a key factor leading and hopefully contributing to reduced student confusion and more clear access to services they need, improved satisfaction, improving success. Information and experiences like that is what this portfolio of work set out to accomplish. So some context before we jump in, largely stemming from the literature review around these services and student success. So self-service platforms to help students conduct the non-academic work of being a student are central to this notion of student success technology. There's some emerging research that shows that e-services enhancements like MyPSU could really reduce bureaucratic hassles which basically means easier ways for students to complete business-related tasks. And then improving those experiences actually contributes to impact influencing persistence over time. Our research doesn't look at that connection with persistence, but there is some data out there that shows that that is something that might happen. One thing that seems to be the case is that college students who have higher financial need might disproportionately benefit from and rely on technology. There was some work at the Georgia State University on a chatbot, and they found that students that had higher financial need tended to engage more with the chatbot for support. And then improving students' experiences could indirectly contribute to retention based on a model by Braxton et al. About student persistence in community colleges, commuter colleges and universities. So in the literature review, it covered a lot of diverse e-service technologies, from enterprise resource planning systems or ERPs to student portals, to mobile services, to mobile apps, to text messaging, to instant messaging. And we also found, of course, that the demographics are changing. I talked about that a little bit before. Students are more financial need, more have children. Universities have large gaps to address as part of this. And the emphasis on first-generation college students as a cohort of students that could really help to move the needle for improving graduation rates. And we also know that students are facile with technology. They tend to be more comfortable than older adults with technology. Almost all own a smartphone or a laptop. So these diverse technologies, changing demographics, the large service quality gaps, and changes in student comfort with technology create the right context for service innovations. So here's the research model. Basically, the research model stems from a body of work called technology adoption models. There are quite a few on the left here. One of the most well-known is the technology acceptance model, which really focuses on perceived usefulness and perceived ease of use. So this is perceived usefulness is how easy something is to use. I'm sorry, how useful something is to use, and perceived ease of use is how easy something is to use. So these models have been empirically evaluated in the past and currently, and they provide the opportunity to select an appropriate adoption model for the research context. And I'll get to which one I chose in just a second, but wanted to pause and just talk a little bit about the anatomy of a research model. Basically, as a whole, the research model affects the researcher's understanding of a theory. And we kind of now can take a look at some of the components of the model. So in these boxes, we have what are called latent constructs or factors or latent variables. They're concepts that cannot be directly measured and must be approximately measured by multiple indicators, or observed variables that could be items in a survey, which was the case with this research. And then we have these arrows or paths between these constructs imply a causal relationship, and so some type of a relationship between the constructs. And there are these moderators that sometimes are studied to influence, to look at the influence they might have on those paths. So for the research at hand today, I chose to use the Unified Theory of Acceptance and Use of Technology, or UTAUT. Here are the main constructs: performance expectancy, effort expectancy, and performance expectancy is really around usefulness. Effort expectancy centers on ease of use. Social influence is what it sounds like, influence from others in using a technology, and facilitating conditions are kind of the supports or things around a technology that might directly influence use behavior. And then gender, age, experience, and voluntariness of use are hypothesized to be moderators in this model. One thing I really like about this model is it includes things that go beyond how easy the technology is to use and its usefulness. Those things matter, but you'll see in my findings and many other studies as well that things around the technology, social influence, facilitating conditions, things like that do influence adoption of technology as well. So this model was modified to fit this context for this study using qualitative methods. Here's a quick summary of those qualitative methods. As I mentioned, the literature review conducted 17 semi-structured interviews of 60 minutes each of a mix of undergraduate students and professionals in the higher ed or ed tech sectors. 2 focus groups of 90 minutes each with 16 participants. One was of students and then one was of professionals from Portland State University. And the experts were really crucial in reviewing the survey instrument as well and giving really great feedback on that. So here's the research model that came out of the work so far. So performance expectancy, effort expectancy, social influence, hypothesized new factor called perceived quality, one called self-efficacy and skills, were hypothesized to influence behavioral intention, which are hypothesized to relate to use behavior, and then these facilitating conditions as well. And so this model was created based on feedback from literature review and the qualitative methods. And it also has some adherence, of course, to UT-AUT, and also a model that's appropriate for being analyzed using structural equation modeling. So here are the hypotheses. I'm not going to spend too much time walking through these, but I do want to call out a few of the definitions that I think are important to understand. So performance expectancy is the degree to which an individual believes that using a technology will help them overall. Again, this focuses on usefulness. Effort expectancy is the degree of ease associated with use of the system. So how easy is it to use? Social influence relates to the extent to which users perceive that those important to them believe they should be using a technology. Perceived quality in this case was users' opinion of the quality of the platform. Self-efficating skills is the judgment of one's ability to perform technology-related tasks and the skills to do so. And facilitating conditions are the degree to which an individual believes that an organizational and technical infrastructure exists to support the use of the system. And behavioral intention is the decision maker's disposition towards using a system. So data collection. The data was collected by distributing a survey, as I mentioned before. Each survey represented an indicator variable in the research model. And the survey questions used a 5-point Likert scale. The survey items were based on items that have been validated in other technology adoption models. The survey instrument was validated through qualitative methods that improved its reliability and validity. And a random sample of 8,000 degree-seeking students from Portland State University was selected as the target population. And the goal was to have a representative sample that was appropriate for structural equation modeling. And here we can see we had 1,841 respondents that composed the analytic sample. And you can see 2,300 respondents participated in the survey, but we narrowed it down here based on adjustments to address non-response bias and unengaged respondents. So yielding a quite solid response rate of 23%. And here you can see the distribution of the survey. It was administered during the time when in Oregon, COVID was front of mind as it is today, given the recent spikes we've had in cases, but that was happening here. And you can see the reminders and how they influence the response rate as well. So in sum, the analytic sample of 1,841 respondents exceeds the requirements for structural equation modeling, and it's appropriate for generalizing findings for the target population. Now we get into the results. I won't walk through the details of using structural equation modeling, but I do want to highlight a few key points. One is that SEM is an iterative process. So often the researcher will go through and look at the data using things like factor analysis or confirmatory factor analysis as part of the work, and looking really at this question, is the model an acceptable fit? And if so, continuing to then evaluate the hypotheses, if not, going back and looking at changes to the model with a really important piece here, which is adhering to the theory. It's really, really important to make sure that any changes to a model are really in line with theory. And that's what I followed in my research. So how to interpret a research model? I want to walk through this a little bit before we get into the actual results. So again, these constructor factors are kind of aggregated concepts that cannot be measured by themselves. And these arrows, again, represent hypothesized relationships between constructs. As an example, here, this construct is hypothesized to influence this construct. And these numbers here, 0.10 is a statistic. It's the standardized path coefficient on a 0 to 1 scale, or they're also called loadings. And they represent the response of the dependent variable or construct to a 1-unit change in the explanatory variable. So for example, if this construct were to increase by 1, a 1-unit change, we would expect a 0.81 change in this construct or factor. And then we have these asterisks here, which correspond to the key here that indicate the level of statistical significance. And last, we also have the variance, this R-squared statistic. It explains the variance that the construct explains, and it also can be translated into a percent, for example, 75% in this case. So here are the final research model results. We can see, and I'll walk you through these in detail, but there were several significant findings, and some of those had fairly strong influences on other factors. And also we had some decent amount of variance that was explained by the constructs. And in essence, through the revised research model, all of the hypothesized relationships were found to be significant. So I'll walk you through those findings in a minute. So I think what's really interesting, both as a researcher and as a practitioner, I think that often many studies find things like effort expectancy or social influence to have some influence on overall adoption. I think where it gets really interesting is looking at these indicator variables. So again, the observed variables or the survey questions that were asked. And those, I think, give us really good clues and information about how we might think about practical significance of findings. And so you hear me talk about that in a little bit. But I want to walk through this taxonomy. So overall, we have use of MyPSU, and here are the constructs that were found to be significant. We have effort expectancy, which really centers on perceived ease of use and includes things like learning to operate, how accessible is the system, whether it includes a mobile app or not, the perceived value independent of time and location, this perceived mobile value, system errors, platform response time, things like that, compatibility with other systems. Then we have social influence, peer influence marketing, influence from university employees, and then learning about a platform, basic computing skills and smartphone skills under the skills construct, and then behavioral intention to use, plan to use, and then use behavior was self-reported by students as well. So when we look at another way to evaluate a research model, in addition to the significance of the paths for the standardized coefficients, is also the goodness of fit. So this looks at the model overall, and there's a really important data to consider whether a model could be considered valid or not. So here we have some of the commonly used measures. I won't walk through the details. I just want to highlight that the model that we just looked at is acceptable, and it's also consistent with an earlier phase in SEM, which is an important comparator, but it was acceptable on these three goodness of fit measures, which are commonly accepted. So here we start to look at the results of the hypothesized relationships in more detail. I want to focus on these effects here because I think they're interesting. We can see that effort expectancy had a large effect on behavioral intention to use. So again, effort expectancy is ease of use. Social influence had a medium effect on behavioral intention, a relatively small effect for skills on behavioral intention. Behavioral intention had a large effect on use behavior. There was a large effect for social influence on effort expectancy and a medium effect for skills on effort expectancy as well. But you can see that these hypotheses were all supported and they were all statistically significant at a very rigorous level with all the exception of one, but still above the common threshold of p less than 0.05. Okay, so here's where I think it starts to get interesting. I think looking at the specific implications of what effort expectancy, for example, means in its relationship to behavioral intention. So for example, leaders, software developers, ed tech companies could think about enhancing content quality and navigation paths to access software, including user interface design, and also ensuring that a platform is easy to access or find in complex digital ecosystems. And access through mobile devices, such as a mobile app, does stand out as a critical component of effort expectancy and ease of use. And you can imagine that makes sense. If you have access to a mobile app, it's probably going to make it a lot easier to use a platform compared to having to go online all the time. And so, forward there. So we see here things like perceived ease of use and learning to operate, mobile app convenience, compatibility with other software platforms and online tools. Those things as a whole were found to influence behavioral intention. Social influence, I think, is interesting as well. Some implications of the work are that universities can amplify their efforts that leverage social influences, such as targeted marketing during students' first experiences at a university and encouraging university employees to promote a platform as well. I think that could be really potent and have a large impact. Also, skills and its relationship to behavioral intention. Universities could support skill building for students who might benefit from improving their basic technology skills. And I think what we find is that there are some pockets of students in universities that do sometimes struggle with some basic technology. And so I think something like this, some skills, foundational skills courses could help. We think here about social influence and its relationship to ease of use or effort expectancy. Universities consider using structured yet straightforward ways to use peers and university employees to walk students through a platform. So you can imagine, for example, at new student orientations, if the orientation advisors and leaders are pulling up the app and saying, hey, here's this app or website you could use, let's walk you through how to use it. Or for example, if a student goes to the technical help desk and the help desk person at the end of a call says, would you like us to walk you through the MyPSU application? Things like that, I think, could really help adoption as well from what this research suggests. And I mentioned before these basic support and tutorials for basic technology skills, particularly for those students who might be less comfortable with technology. So in summary, these implications are that first, this research provide insights for universities in the ed tech sector about how to improve service delivery through technology-enabled services. Second, it offers leaders, managers, and software developers in universities ideas for concrete action to improve student information technology. And finally, this research suggests ways to enhance software in support of institutional and societal goals to improve student success. So concluding then, in terms of research question 1, what are the critical factors that influence undergraduate students themselves in adopting software for accessing university services? Ease of use and social influence stand out as critical influences on intention to adopt a technology, and social influence in a student's basic technology skills stand out as determinants of ease of use. A large part of the variance for effort expectancy and behavioral intention and use behavior was explained by the research model, which is really positive. And this research question 2, I won't go into too much depth here, but the question was basically, what do we think about the UT-AUT model having done this research? I think the findings are that it was partially validated. Some of the key constructs did show up in the model. I think that more complex relationships exist between latent variables than a strict application of the UT-AUT model affords. In a higher education context where this research was conducted, skills is an important factor that could be added to UT-AUT. And one important note here is that the findings from this research are just one model. Often there are other models that could fit the data just as well, or perhaps fit the data even better. So there could be other applications of UT-AUT within this data that could build on the findings to date. And so in summary, this research uniquely contributes to the research literature. There's a novel application of UT-AUT to a higher education context to study service delivery. The work explains critical determinants of student information technology adoption and improves understanding of how UT-AUT could be applied in the university setting. So with that, I'll wrap things up and say thank you. Here's my LinkedIn profile. Feel free to submit any comments or ideas via LinkedIn. And I think that's it. I'll stop my sharing.
Thank you so much, Hans.
Yep.
Thank you. Are there any questions? Please.
Oh yeah, hey Hans, thank you very much. I saw you when you were talking there with our class, the other class, which is whatever it is, 640. So and I got in late on this one. I do apologize for that. But I noticed that one thing you did say was that the mobile app makes it easier as opposed to having to go online all the time.
Yeah. Yep.
Now I thought going online was like fabulous modern technology. What is with this phone thing? I believe that your idea for foundational skills to help technologically challenged students is a really super good one, because I would be that technologically challenged student. I mean, using the phone is not one of my skill sets.
Yep.
And that as an adoption method would be really critical, I think.
Yep.
That's my
Thank
opinion.
you. Yeah, no, that's great feedback. I think, so where does often in user experience and technology adoption, we think about friction points. And so as I mentioned, going online, some folks that are a little more technically savvy, they can go open up their browser on their phone and they can type in a web address or URL. Like in this case, it would be my.pdx.edu. One thing that's nice about mobile apps is there, you can click it on your screen. Oftentimes the login can be a little bit longer. You can use, if you have touch or face ID, you can use that to log in a little bit more seamlessly. You can have your web browser remember that, but it's not as easy to do at times. So there's some, I think, particularly for students that, when we're on campus, moving around and moving from space to space, transit, on the bus or the MAX, things like that, having a mobile app seems to have stood out for students. And I think it's something that is important to consider. So glad to hear your recommendation for the courses. I think that we make the assumption sometimes that everyone's facile with technology and can use it really easily. And I think there are some foundational skills that showed up in my interviews and in the survey too, I think that would help students as well. Yeah, thanks for the comments and question.
I think I missed if you mentioned it, but my question is it like available for all the students or only, I don't know what you mean by higher education?
Sure. Yep. So, sorry, higher education is a term that means universities and colleges, and also can include community colleges as well. And so the app that was studied is currently available to all Portland State University students.
Okay, thank you.
Mm-hmm. Yep.
Thank you, everyone. And thank you, Dr. Van der Schaaf, for being a part of our lecture series.
You bet. Thank you, Dr. Dime, for all your work, and students, you're in amazing hands if you haven't figured it out yet. Thank you, Dr. Dime, for all your work.
Thank you. Have a good day. Bye-bye.
Take care. Bye.